Okay, welcome back. This is a new Stryker 955 for RZAC in Maryland, I think. So here it is right here for you. Here's your mic. Got a battery in there for you, so you'll be good to go. Just when you use that mic, if you're going to use it with this radio, just run the radio in the dynamic mic type setting. I'll probably leave it in there. I think it's default anyways. I'm going to use mine when I show you the radio. Same mic here. I won't use yours other than I just threw a battery in it and made sure that it worked. So right now what I'm going to do is we're going to go into the S meter adjustment mode, and I'm just going to run through all the steps. I'll do that in FM because that's where you do it, and then I'll do it in upper side because that's where you do it on these ones. So I'll make sure those are all correct, like I always do, and then we'll come back and take a look at the power and stuff later. I haven't made a video on one of these in a while, so I just figured I would do it really quick. I seem to, usually by Friday, for whatever reason, I like to put a video out on Friday, I guess. I'd like to do more. I'd love to do videos for everybody, just time doesn't allow it, and that's kind of where we're at. So we'll get back on this one in a minute. Alright, you can see I got the radio switched over. Just going to show you the bands. So I have it in VFO mode because I think you asked me about that. I have it in 5K steps. You can adjust that in the function menu. You can adjust also how this interacts. I have it in 1K. So I think that'll give you a good interpretation of how you can move around the band. If you don't like that, you can switch the functionality of this and this in the menu. So I'm checking receiver sensitivity right now. We're on lower side, so we will dip that down. Let me actually see what I got going on here. Just 1 second. Bear with me here. I want to make sure that I have this right. Okay, so got it right. When I switched back to band mode, I kind of screwed up what I was going to show in the beginning on the test here. So S9 minus 67 dBm, which is what these 10 meter manufacturers set them to. So I know a lot of you guys would say, well, why not minus 73? You can do that, but I like to stay with what they go with, so it's minus 67. Ranger, everybody else seems to follow that too, for whatever reason. Maybe just to be different. Sensitivity on sideband, so we'll just see where it falls in at. I think it's going to be about minus 128. Yeah, so they always turn out good. There's a minus 128 with the attenuation device there on the output of that. There's our 12 right there, so that's working well. Alright, same thing on AM. 67, minus 67 dBm. And 30% modulation, S9. Let's come up here and we'll take a look where it comes out to about 12. I'm just going to guess about 114. Actually, just a little bit more gain on this one, so there's 115. The volume's down just a little low on it. If I bump the volume control up, it will level itself out like that. That's down kind of. Goes down a little low. There's minus 115, so that's outstanding. That's better than what the radio oddities and the any tones and whatnot fall in. So this has just a little bit more gain. Probably won't notice it on the operating side, but I notice it here, so that's good. All right, here's our transmit frequency, so pretty much spot on. Awesome. We're in the test mode here. Didn't have to change it, so that's going to be for AM FM, so that's great. Alright, FM power high, right about 50. Actually, give that just one more bump here. There we go. So right around 50 anyways. It's going to be relatively close. So, and then I'll set the low power to 1. Alright, here's our FM deviation. So look at that top scale between 3 and 4. If you take the 0 off the 30 and the 40, that's what we're looking at for deviation in kilohertz here. So I was pretty darn close out of the factory. I only adjusted it, just a couple adjustments, but I like what I see there. So it's going to sound really nice on 10 meter FM, or I guess anywhere else on FM. So If you have an amateur radio or something and you listen to this radio, it's going to sound outstanding on FM. If you have a CB like the George FCC or one of the new Radio Oddity CB500 or the Anytone AT500M Mark II, the radio might sound a little too loud to you, this radio, because of the difference in deviation. Although I believe the new Anytone AT500 Mark II and the CB500, if you do convert the radio, which probably most would do anyways, there is an option for 2 to 4 kilohertz. I don't know if that shifts the receiver passband or not. That would be something I would have to test, and I just haven't had time to test mine. Mine's still sitting down underneath my desk here in the box because I really haven't had much time to really dig into that radio like I wanted to. So that's neither here nor there. That's going to be a project for a later date. But just keep in mind that there are differences between the two. Alright, so we got your AM. See the carrier's all blown up here, and there's a reason for that. So, because I wanted to show you the middle, so that was the AMC kind of ramped way up, and then it caught it. So there's a high level of modulation here. That's why I wanted to show that, and it did set the beep off on the meter, which is normal when you have a ton of modulation. So what I don't do, and what I've seen a few come across my workbench here before on this model, is I don't leave it like that, how it was in the beginning, how it ramps way up, and that's what some people do. They modify the circuit somehow, which I don't know why you'd want to make it stay like that the whole time you're transmitting, which makes you ungodly loud, but also ungodly dirty on the RF spectrum. So here's the spectrum analyzer right here. It's 27205. One channel over here, one channel over here. Everything else in between looks really nice. So we can see here why I'm showing you this blown up is we can see the middle. It's not pinching off or anything. So now I'll zoom this back out some, and we can focus our needs on the top here. So you can also do this. Takes a second. See, that top is nice and sharp, and the bottom will mirror that. So if we do this and get ourselves back around, this is the low power modulation here. So nice and round, sharp edges all the way across. So that's why I showed that. And we're going from 1 watt on the average side to like 5, which is 5 times. That's huge. That's usually what you get on AM, 4 to 5 times on peak. This is average, so all that other average swing is senseless. It's dirty for the RF spectrum. We're almost 9 times on the peak now, so I think that's plenty. I think doing those modifications is definitely unnecessary and really bad for the RF spectrum, because we are responsible for what we put out into the airwaves. Whether we're talking about CB or amateur radio, I think we should all hold ourselves to a higher level on what we put out there. We want to sound good. Everybody wants power. We want to sound good, but we should be more concerned with how does the signal look going out versus everything else. Alright, so this is the high power modulation. So I do set these now for about 10. So it's 1 to 10 on the RF power. Usually, I used to set them 1 to 8, but now I do 1 to 10. And that's just something that I've changed. So you can always get 8 still just by lowering the RF power dial. Okay, so we're looking at the AM mod. I want to try to make it just a little more aggressive. Not too aggressive. You go too aggressive, it does that. And then what happens when you do that is this. So you're almost putting out as much power into the next 2 channels as you are in the one you're on. So that's why I don't do that. But that's like when they mod it or whatever they do. I think they just pull the surface mount component out that controls AMC, and then it's just downright gross to look at. And also probably adjacent channels when you're talking are even worse, because when you speak, the AMC is even less aggressive than what it is with the tone. So by pulling it, you got nothing. So that's what we have there. I think that's pretty good. It's not pinching off or anything in the middle, so it's a nice zoomed in look there. And then we'll zoom it out. So take a look at the top and bottom. I'm not gonna really, I can probably do it like this. Would be a good idea. It's nice and rounded on the top, and the bottom mirrors the top. So what we see on the bottom will mimic exactly what we see on the top. Just like that. So nice sharp edges, and looks really good up here. So that's all we need. And we were starting at 10, and now we're at like 20 something. So that's pretty good. Let's go to the peak, and we're starting at 10. Now we're at like 40 something. So you get a little more audio with the dead key down. That's normal. But still, we're at what, about four times, a little over 4 times, which that's perfect. So AM is done. Now I'll look at sideband. All right, here's your sideband two-tone. This is factory again. This is nothing out of the ordinary. I mean, this is normal. So not looking too good by any means. It's upper sideband. So obviously, this is upper sideband going up in frequency, but we have a lot of power still being generated on the lower sideband here. And if you just run this normal, like this, the radios I've seen from the different places usually didn't change anything here. They just left it the way it was, which was really bad anyways. And then you run a big amplifier behind this. I mean, it's just going to be god awful to the band. The radio will probably sound good, the clarity and everything. These are very clear, well versed and understood radios with modulation. That's not the issue. The issue is more, like I'm saying here, the RF spectrum. And if you have like a guy with a waterfall display on his Yaesu or ICOM, he's going to look at that and be like, good Lord. And you just don't want that. In the sideband world, it's all about cleanliness of signal. And you're just wasting the energy. Like right now, where are we at here? We're like, this is the little w means average. So we're very high power right now for at a cost of a lot of it's in here, which should not be there. This should really drop down. Now these radios only allow you to do so much, but we're going to see a decrease here, because power radiating here on upper side is a total waste. This almost looks like an AM signal if you look at it. You know, there's obviously more power on the upper side, which is normal, but it almost looks like we're generating AM right now because of the way it looks. So you don't want that. All right, so we're gonna make the change now. So just watch the lower sideband right here and watch this oscilloscope. Maybe I can back up some so we can kind of all look at it together. You'll notice as this starts to round, this starts to drop, and it also will start to drop some here too. So it's not fully round yet, but it's getting there. So, and also the power is going to drop on the average side. It's all together. You want all three things to kind of work together. There, it's starting to round off, and you see all that drop down? All that stuff in here. Remember, this is the next 10 kilohertz this way. So now we're really cleaning up that signal versus like that. So that's looking better, but you can see our power dropped to about half. So you have to realize if you want a cleaner signal, it's got to be tighter, it's got to do less power, and that's just the way it is. I mean, there's no way around it. Now we're occupying way less bandwidth. In the power bandwidth, the power is being distributed properly. Now, could you do better? Yeah, if the radio would let me, I would love to make it do better, but this is pretty darn good for what we're looking at here for this radio. So that's the biggest thing there with these and the anytones and the radio oddities. You really need to clean that up, because if you don't, you're not doing yourself a service. You're doing a lot of power on the watt meter, but the power isn't going where you want, and that's the main thing. Get the power out there, but get it out properly. So I can probably I bumped that up just a hair, but you know, it's looking really good now. Really good, like it should. So let me actually back that up some. We got Easter coming up in another month or so, I think. I like to say these kind of look like an Easter egg. You guys watch my videos a lot, probably have heard me say that, but it's a pretty thing when it turns out well. And then here's the power. Obviously, it's dropped way down, so nothing to worry about there. So we're pretty much done with the alignment there, RZAC. And now I'm going to get out of this, and I'll come back with the radio in the standard operation. We'll take a look at the power, then that's going to be it for you. Really quick, I wanted to show you your transmitted frequency on sideband. So we're in lower side with a 1 kilohertz tone, so the signal shifts to the left now. So this number becomes a 4 on the counter, and you can see that here. So if we do this, and I'll pause this because it takes 10 seconds. So look how nice that looks. Really can't ask for anything better than that for like a 10-12 meter radio, so that's awesome. And that's just the way they are ever since Quicksand came out with these new boards that they've had a lot of success with. I mean, I just can't say how nice it's been to not have to worry about being on frequency and stuff anymore. And you're hearing that more and more, especially on sideband. You see it more and more, I mean, and you hear it when you're on the sideband channels, and everybody's almost on frequency now. It's a crazy thing, you know. 10 years ago it was kind of a free-for-all. There'd be so many guys that were off frequency, and not always the person's fault, because some radios just aren't capable of giving you a high level of sideband performance. So these are exceptionally good for that. So I just want to show you something with the VFO. You can obviously, if you go into the function menu, the fine clarifiers here, you can always change how far that goes. It's 300 hertz right now. So if you hit the button again, whoop, the course is this one, so you can change how much you want it to go. Between 10K, 5K, and 1K. I leave it at 1K. The channel selector is here. You can go all the way up to 1 megahertz. So we'll just leave it there for a second. This is how I recommend running these. You can go all the way down to 12 meter. Actually, it's well lower than 12 meter, and all the way up to 30. So obviously, make sure you have a license if you're going to use these frequencies. But yeah, I mean, if you feel comfortable using just a frequency readout, it's much easier to use the radio like this. Now I'm going to switch that back to 5 kilohertz, because I like to move around like that. Whoop. Auto squelch, I'm going to leave that off. So let me get out of the menu. Thought I already was. So now we're going jumping 5. So. But if you don't like it, switch it back to the band and use it in the band mode. That's up to the user. I'm going to leave that up to you. I'm going to leave it in VFO. Just one thing to point out before I show you the power. I'll put this in FM mode. Oh, let me pull the external speaker out. I'm still hooked up to the meter. I want to show you the noise reduction. Mic type is already in dynamic, I believe, so don't worry about that. Yep. Noise gate, I'm actually going to switch that on. Oh, sorry about that. Noise reduction on. You can hear how that cleans up the signal. So I'm going to leave that noise gate on. You can switch that off. What that does is take out some background noise out of the transmission. So leave that on. Let's hook the mic up now and we'll do some power checks. Okay, here's the power check. So we're on 13.8. I'm using this little Radio Shack switching unit here, so I'm assuming it's 13.8. I have never tested it, so we can only assume it's 13.8. It really doesn't matter. The radio kind of does what they do. This is real power with a real alignment here, so results might vary with other ones, is all I can say. So obviously when we transmit on sideband, you're not going to see a huge jump on the power meter. That's normal, so don't be alarmed by that. This is with the RF power all the way up, by the way. Okay, So power on the radio with the RF power all the way up here is about 50 to 55. That's what they do. So, you know, if you want clean power, this is where it's at. If you want the dirty power and everything else, then, you know, it's going to do more. But as I showed you in that last section when I had the spectrum analyzer going, that doesn't help you at all. So there's no difference between this power and say 80, 90, 100 watts. I mean, it's not going to make any noticeable difference on the receiving end, other than it makes you happy on your power meter. So just keep that in mind, you know, when you want better performance, like this is going to always work better. So you're going to find with the expensive ham radios and stuff like that, they never do the full 100 usually on sideband. They always do a little bit less, like 80 to 90, somewhere in there. So it's just the way it is. They want spectral purity. They don't care about power. So here's the low side of sideband here. So you got about 5 to 10 watts probably somewhere in there. So 1 2 3 1 2 3, check. Okay. So now we'll do AM. We'll start on the low power side, which is about 1. Assuming when we talk it's going to swing kind of all over the place. It does not mean we're swinging 1 to 80. So it would be nice if we could do that clean, but it's not possible. So but the radio is telling us we are. So, but anyways, about a 1 watt carrier here, about 1 watt. And then when I speak into the mic, you can see it's swinging almost the max power. So there's a ton of modulation at this low power setting. So this is kind of an audio machine radio for what it is. So that's why we're hitting those big peaks. The AMC is less aggressive here, so it kind of slips a little bit, and that's what's giving us those big jumps of forward power like that. It's not necessarily the cleanest like this, but this is how the radio is made. It's made for like a stronger AM punch. So that's the way it is. So with the tone, it's very clean. But then if you remember, we were only doing like 8 or 9 watts peak. So you have to remember with these radios, they are designed a certain way. And AMC with voice is much less aggressive. It's harder for it to catch because our voices have different emphasis to them, you know, highs and lows and in-betweens and words. Every word is different. So by the time the AMC tries to catch, we're saying a different word, and it just cannot, it needs to beat in on that tone, and that's why you set the audio like that. So it kind of is what it is, but you know, a lot of guys don't really catch that part, I think. And there's an option on the scope, I think I've showed it before, with the peak persistence, and you can see when you speak, you can see those peaks, and some are small and then some jump way up. And if we were to look at that where it jumps way up, it'll also show here where it jumps way up. So everything works together. It's all like a sequence. So what I want to do now is set this to about 4 watts, which is about where it's at. About 4 watts here, and let's talk into it. So even at 4 watts, we're doing pretty good power. This is a good area to run this radio on AM. If that's where you're going to run it, you're going to get a good modulation and good forward power out of it, like here. If we turn it up all the way to 10, it's actually about 10.5. So at 10, you know, the mod starts to drop just a little bit at the higher power level, so don't be alarmed by that, but that's normal. The lower dead keys are going to give you a little bit more peak power and a little more mod. If we set this back to 8, I used to like to go to 8, but I've been going to 10 because there was a couple customers that said they liked 10 when I did it for them. And I figured 10 probably won't hurt. You know, you can run it there, but it's close enough to 8. 1 2 3 1 2 3. Even at 8, it still kind of does that. Maybe just a tad bit more audio, but not really a ton. So, you know, I say somewhere between like 2 and 4 is probably good for AM, and just let it rip. You know, keep the mod all the way up. If you're going to run the mic with it that you bought from me, keep it at about the V or something on the volume dial right here, the little indicator there, and you should be set. So that's pretty much it for your RZAC. Talk back and all that stuff is here. Check 1 2 1 2 with that noise gate on. It probably won't squeal as much. So check 1 2, check 1 2. Hello, check check 1 2 1 2. Echo. I'm gonna play with that. Check 1 2 1 2. Check. So everything is good on this guy. So I'm just gonna shut everything off for you. Get it boxed and ready to send off. Kind of a long video, but covered a lot, I think. Wish I could do these for everybody, but just time doesn't allow it. So probably won't hear from me for a while on YouTube. I'll reply to the comments when time allows and everything. On a side note, I had a couple radio failures this week of my own. It was a bad storm we had about a week or so ago. Nasty thunderstorm, lightning like crazy. Had a tornado pass through the town. My town, luckily nothing hit me or anything like that, but the radios were affected by the, I think, the static electricity buildup of the lightning. And it was both my ICOMs, my 7300, which is out of warranty, and my 9700, which is in warranty. So I sent the 9700 first per their request. Hopefully they will fix that one and get that one back to me, because I actually use that more. And the 7300 will be an out-of-pocket repair, so I'm not really looking forward to that. That's kind of a backup HF model, but I've had it for like 9 years. I like it. I'm gonna get it fixed as long as it's affordable. But yeah, something to, I guess, learn from that situation is unplug your equipment, power supplies, everything. When I leave here now, I make it a habit to unplug my power strips under the desks. All that stuff gets unplugged. The antennas get unhooked from the radios. I have grounding apparatuses outside for my HF and my CB antennas, but I do not have one for my VHF right now. But even that didn't help, because I have lightning arresters hooked up to ground rods, the whole 9 yards. Something happened with either there was a power surge that came through the wall plug, somehow passed through the power supply, went into the DC cord of the radio. Something happened, or else it was a high level of like static electricity that came through the antenna. The antennas worked fine, everything is working well there, but the radios suffered some issues. So the 7300 is much worse than the 9700. The 9700 just lost some power output. It's doing like 50% out, which is the 100-watt rig. It's only doing like 50 on 144 to 148. So kind of an odd situation there, but something to learn from. Let's keep our stuff unhooked when we're not using it. I know it can be a pain and everything, but it can save you in the long run. Otherwise, if you have like an extensive grounding apparatus, maybe even then, I would still recommend doing it just to be safe. I mean, we hope that stuff will help and fix and work, but we really can't say, because lightning is very dangerous and very strong, and it's very unpredictable. So thanks a lot for the order here. We'll get this shipped off to you. You can obviously change the color if you want. I like the orange. That's just personal preference, but all the colors are here. One thing I like to recommend is keep the dimmer at least at 50%, which is here, or less if you can. The higher you turn it up, the brighter the screen gets. Well, again, I don't know how long these will last. It's got a 2-year warranty, so you're good for at least 2 years. But I still recommend running it at a lower level of backlight. That's just my personal opinion. All right, catch everybody later. 7-3.